So we use the solubility chart for a double replacement reaction. Is that right? Now, here is, it says aqueous. So we know nickel 2 nitrate is aqueous. Nickel is the metal, right? Nickel is the metal, nitrate is the non-metal, and then cesium is the metal and hydroxide is the non-metal. Can somebody tell me how will they switch? What will the products be when you switch? Anybody in class? What are the products formed? Alright, so you will form nickel 2 hydroxide plus cesium nitrate. Is that right? Cesium nitrate. Now, you have to know the state symbols for these compounds. Can somebody tell me what is the state symbol for nickel 2 hydroxide? You know how to use your solubility chart and figure it out? Can somebody tell me what it is?
Solid.
It's a solid? Are you able to conclude that? What about cesium nitrate? Is cesium nitrate aqueous? Alright. So we've done this before and we'll see what writing a net ionic equation is. So I need to write the formula for nickel 2 nitrate. Nickel 2 nitrate is NiNO3 2. Is that right? Plus cesium hydroxide is that. And then you have nickel 2 hydroxide, which is NiOH2 plus cesium nitrate is CsNO3. Now, the equation is not balanced, so you need to include a 2 for the nitrate, which means there is a 2 before cesium and hydroxide, and the equation becomes balanced. Is that correct? Everybody with me so far? When we say a substance is aqueous, that means that substance has dissolved. Correct? If it has dissolved, it means it has broken up into its ions when it's in water. Because the ions are so much more smaller, and as they're separated, we are not able to see them. That's what dissolved means. Is that right? They're breaking apart into their ions. So, you should know to say aqueous means what has happened to nickel 2 nitrate. It has become nickel plus 2. Are you with me? Plus, how many nitrates are there? How many nitrates are there in the formula? 2. So you write a 2 and you write NO3 minus. I need to see the charges to tell me that they are ions in solution. Does that make sense? You need to split them into their ions. Plus, there is a 2 in front of cesium, so it's 2 cesium plus, right? Does the 2 distribute over to the hydroxide also? Is that right?
Yeah.
Are there 2 plus 2 OH minus? Is that correct? Yes, John.
This NO, where you have a -2 charge.
So, NO3 is a -1. Okay? It's a -1 charge. So that is my reactant side. Now I'm going to write my product side. Did we say nickel hydroxide was a solid?
Yeah.
Did we say it's a precipitate? When it's a solid or a precipitate, you never break it apart. Are you able to see it in a solution when you make the precipitate? That's because it's come together. Does that make sense? It's all a solid. So you don't break up a solid and you write it as NiOH2 plus your cesium nitrate is aqueous, right? So you break it apart. You make it 2 cesium plus 2 nitrate minus. Do you understand this so far? Yes, John.
Where's the 2?
The 2 is the balanced equation 2. You see that?
Oh,
and the two distributes to cesium and the nitrate. Now, just for the sake of space, I'm going to continue this problem here. All right. Now, what are the ions that are common on both sides? Do you see a 2 nitrate here and a 2 nitrate here? You can cancel it out because it's on both sides of the equation. Do you see a 2 cesium and a 2 cesium on both sides? You can cancel it out. Can you cancel nickel with nickel hydroxide? No, you can't. So what is left over after you cancel the common ions? The common ions are called spectator ions. They are ions that do not participate in the reaction. Does that make sense? So what are the ones that actually participate in the reaction? Nickel plus 2 hydroxide minus gives me nickel OH2. This final equation is called a net ionic equation. What is this called? It's called net ionic equation. And if given a reaction like this, you should be able to write a net ionic equation for that reaction. All right? Yes, John.
why didn't you write the charge on the product side? Did you just not do that?
It is a precipitate. It's not breaking up into its ions.
So,
You cannot write charges. It's a compound. Compound is neutral.
okay, and another question.
Mm-hmm.
Is this basically just using the double replacement?
Yeah, the double replacement, but now you're breaking it apart. You're telling me what is the reaction that's actually happening in the liquid.
So the only difference is you write the charges and then cancel out.
Yes, cancel out. Okay? Yes,
So
Melanie.
this can only happen with double replacement reaction?
Yes, this is only true. Well, you can write net ionic equations for a single replacement reaction. We can write it for all reactions, in fact. All right, we'll practice a few of them. All right, let's look at number 3 now. I cancel number 2 for now. Let's do number 3. All right, we'll come back to number 2. So it says aqueous solutions of magnesium nitrate and sodium bromide are mixed. So it's going to combine and give me what? Magnesium bromide, right? Magnesium bromide plus what? Plus sodium nitrate. Is that right? Can somebody tell me what is the state symbol for magnesium bromide? Is magnesium bromide aqueous or a solid? It's aqueous. What about sodium nitrate? Is sodium nitrate also aqueous? Okay. So let's try and see if there is an equation for this reaction, a net ionic equation. So I have magnesium nitrate, which is MgNO3 plus sodium bromide, which is NaBr, giving me magnesium bromide, which is MgBr2 plus sodium nitrate is NaNO3. Now I need to balance the equation, so I need a 2 there, all right? And I need a 2 there, and my equation is balanced. Is that correct? The state symbol for all of them are aqueous. Everything is aqueous. Is that right?
So nothing no reaction.
That is correct. And we can show that through the net ionic equation that there is no reaction because all ions will end up canceling. All right? Does that make sense? So you break it up into what? Mg plus 2 plus 2NO3 minus plus 2Na plus 2Br minus giving Mg plus 2 plus 2Br minus plus 2Na plus 2NO3 minus. Right? So the Mg and Mg will cancel. The 2NO3 and the 2NO3 will cancel. The 2Na and the 2Na will cancel. The 2Br and the 2Br will cancel. Do you see that? There is no net ionic equation, which means it translates into what? That there is no reaction. Does it make sense? Okay. What was the second question? Let's do the second question. What was the second question? Can I get a sheet, please?
We only have 2 minutes.
We only have 2 minutes. Should I stop? We did one that works and one that didn't. Is that right? So why don't you try the others that are there in this practice sheet for homework? Okay? And I will post an answer key to these so that you get the practice. All right? Hopefully, yes. We'll comment, we'll do a warm up, and then we'll have a quiz. All right? Once we practice it. All right?